Hi, I'm Emily Hammett from the University of Montana, and this is my senior thesis work titled Are There Meal Plants in Streams Leaf Preference of an Aquatic Invertebrate? So, as you may know, allophonous inputs, or leaves and other debris that fall into the stream, form the primary linkage between the terrestrial and aquatic worlds. These leaves also form most of the nutrients that are found in the streams. Once the leaves enter the stream, they go through a three-step process. First, a leachate process where all the water-soluble compounds exit the leaf. Second, they go through a colonization process, which is where microbes and other bacteria colonize the leaf. And finally, they go through a fragmentation process where our shredders, our macroinvertebrates, eat these leaves, fragmentize them, and then basically send them on down the food chain. So there's variation throughout all of this, and I wanted to know how the conditioning time, or the leachate and colonization process combined, affects the fragmentation process. So to do that, I collected macroinvertebrates, these shredders over here, Pteronarchus californica, the giant salmon fly, from Rock Creek, this area, along with 5 different riparian species: willows, alders, chokecherries, dogwoods, and cottonwoods. Once I did that, I took the leaves and put them in 2 different conditioning times: the 7 days of conditioning and 25 days of conditioning. Once the conditioning times were complete, I put them through 2 different experiments: a growth experiment, where I fed these salmon flies only one type of leaf, and a choice experiment where I gave them 2 different types of leaves, either cottonwoods or one of the other species, and measured how much they ate of the leaf and where they were located. And this all happened over 2 weeks. So I found that between 7 days of conditioning and 25 days of conditioning, there is a preference, a shift in how much they ate of each leaf. So you can see that here in these graphs. Each color represents one of the arrays where it was either cottonwoods, which is on the left, or one of the other leaf types. And this top graph is 7 days of conditioning, this bottom graph is 25 days of conditioning. So you can tell between the 2 conditioning times that there's definitely a shift, especially between cottonwoods and alders and cottonwoods and willows, of how much these bugs were eating. However, this does not match where they were located. They generally tended to stay on larger leaves, but they ate the smaller leaves first. And over here on the 7 days of conditioning, they ate more of the populace, but they had eaten all of the willows before they ate the cottonwoods. Okay, so if what they're eating does not match where they're located, maybe what they're eating affects their growth. It doesn't. I found that there was no difference between leaf types on growth, and also no difference of conditioning time on growth. And you can see this on this bottom graph here, where there's not really any patterns found. Okay, so if it doesn't affect their growth, maybe like leaf toughness explains why they're eating these leaves first. It also doesn't. We measured leaf mass area, which is highly correlated with leaf toughness, and there's no correlation between what they were eating or how much they were eating and leaf toughness. So we know that there's definitely a shift of consumption as conditioning time lengthens. You could find that here, but this does not match where they were located. They tended to be on larger leaves, how tough the leaves are, or any effect of growth. So, therefore, is a leaf just a leaf to these bugs? I think not. They tended to eat the leaves that were disintegrating faster before they ate the cottonwoods. So chokecherries were pretty disgusting. They were like these weird globs by the time after 25 days of conditioning, but the cottonwoods looked basically the same. And so I think that we still need to plant a variation of trees in these riparian areas for these bugs because they need a constant food supply. And the only way they're going to get that is if we have a variation of trees, because these leaves disintegrate at different times. And it could be, which is something I want to know, it could be because of macronutrients or of secondary compounds in the leaves, which is future questions. Thanks.